Morning, guys. Happy Monday. Okay, so I'm going to start with correcting the homework. So this homework was originally given on Wednesday, and then I kind of made it Friday's homework because the class was cancelled. So this is what's due for today. Okay, so we'll go through this first, and then we'll go in and finish off the chapter, which is great. Okay, so what is the volume in litres of the smaller tank? Okay, so it's a cuboid, which means the volume is going to be length by width by height. So what's that? 50 by 40 by 60? Yeah? So 50 by 40 by 60 is 1, 2, 4. 1, 2, 3, 4. So 120,000 centimeters cubed. But remember I told you that centimeters cubed are the same as mils? Yeah? And then it says it here. Oh, actually they made the conversion straight, so we didn't even need to go to mils, but it doesn't matter. Okay, so we're going to convert from milliliters into liters. So that conversion is going from a small unit, milliliters are tiny, to a big unit, like a litre of milk type size. So that means we divide, because we're going from small to big. And then how many milliliters? You can see it over here. There's 1,000. So I'm going to take my 120,000 milliliters. I'm going to divide it by 1,000. And I get a volume of 120 litres for the little one. Same question for the big one. So 80, 60, and 75. Okay. So with height, 80, 60, 75. Did I get that right? 80, 60, 75. Yep. Okay, so same thing. 80 by 60 by 75 is 360,000. And that's centimeters cubed. Convert that into mils. And then same thing, we're going to divide by 1,000. So it's 360 litres. For the big one. Right. By how many times is the capacity of the larger tank bigger than the capacity of the smaller tank? So by how many times means I have to divide. So I do my 360 litres and I divide it by my 120 litres, and that gives me 3. So the big one is 3 times bigger than the small tank. Yeah? Okay. A third tank holds the volume of both tanks combined. Its length is 120. Its breadth, and remember breadth is just another word for width, is 80. Find the height of the third tank. Okay, so if it holds the combined capacity of the two of them, that means it's going to be, I have to be careful because this is in centimeters. So I'm going to need to go back to centimeters. So the small one was 120,000. And the big one was 360,000. So that means this new third tank is going to hold, 480,000. Okay? So the volume is length by width by height. We know the volume because it holds 480,000. The length is 120 multiplied by the width or the breadth, which is 80, and then multiplied by the height, which we don't know. Okay, so same as before, we're trying to get the height, so you do what you can. So this is multipliable, so we'll multiply it. So 480,000 equals, 9,600 by h. So the 9,600 has been multiplied by h, so to get rid of it, I will divide by the 9,600, but if I do that on the right, I have to do that on the left. And that gives me a height of 50 centimeters. Okay. Okay, so a cylindrical saucepan and cup are shown. The diameter of the saucepan is 30, so I'm just going to do this now so I don't end up getting confused. If the diameter of the saucepan is 30, I'm going to make a note that that means the radius is 15. Yeah? And the diameter of the cup is 9. That means the radius is 4.5. Okay? Just in case you got mixed up later. So A, find the volume of the cup and give your answer in terms of pi. Okay, so they said it was a cylinder, and the volume of a cylinder is pi or squared h. Okay, so pi we're going to leave because they want it in terms of pi. The radius I've already written down is 4.5, and we're going to square it, and then the height is 10. So I'm going to type this into my calculator. I'm going to go shift pi, bracket 4.5, bracket squared, bracket 10, bracket. That's what I've typed in. And when I press equals, I get, it says in terms of pi, so 405 over 2 pi. And it's a volume, so centimeters cubed. If you didn't like the fraction, you could do 202.5 pi centimeters cubed. So that's just either expressed as a fraction or as a decimal, but you have to keep the pi because the question says in terms of pi. Yeah? Okay. The saucepan holds 20 times the volume of the cup when full. What volume of soup does the saucepan hold? Okay, so it holds 20 times the cup. So this is what the cup holds. That's what the cup holds. And the saucepan holds 20 times that. Multiplied by 20. Now. So I am getting that the saucepan has a volume of, or has a capacity of, 4050 pi centimeters cubed. And yep, they also want it in terms of pi. So leave the pi. Okay, so what is the height of the saucepan? Oh, what happened there? All right, so the saucepan's a cylinder. So the volume of a cylinder is pi or squared h. We know the volume. It's 4050 pi equals pi. I think we know the rate, didn't I? Yeah, so the radius is 15. We know the radius. So that's 15 squared, and then the h is what they're looking for. Okay. Okay. So I'm going to square the 15 because that seems like the... So I'm going to leave this alone. And I'm going to do 15 squared, which is 225. So that's 225 pi h. Yeah? So basically what I did there was I multiplied these two together. Again, anytime you have that idea of like a couple of things multiplied together, you can multiply any two of them. So I multiplied those two. Okay, so I'm trying to get the h, which means I have to get rid of the 225 pi. I do that with division. But if I divide by 225 pi on the right, I have to divide by 225 pi on the left. So 4050 shift pi divided by 225 shift pi, and I get a height of 18 centimeters for the saucepan. Okay? And for safety reasons, the level of the soup in the saucepan is never more than 16 centimeters high. How many full cups of soup can you get from the saucepan? Okay, so we know that the total height is 18 centimeters, but we can't fill it to 18 centimeters because it's not safe. So you can only fill it to, oh, that doesn't look like 16. Maybe there. Okay, we can only fill it to 16 centimeters. So in terms of the holding capacity or the ability of the saucepan to hold liquid, it's as if those top 2 centimeters don't exist, because if you can't fill it, then they may as well not exist. Okay, so what you have is a cylinder, but the cylinder only has a height of 16. So we do the formula for the volume of a cylinder. Okay, so it's pi. The radius of the saucepan is still 15. That hasn't changed. But now we can't fill it completely. We can't go to that 18 centimeter height. We can only go to 16. So that's how much liquid it will hold. So shift pi bracket 15 bracket squared. Oh, wrong bracket. Bracket 16. And that is giving me 3,600 pi centimeters cubed. So that is how much soup it can hold safely. Okay? Each cup was this 202.5 pi. So if I do 3,600 pi divided by 202.5 pi and see how many cups I can get divided by 202.5 shift pi, and how many cups I can get out of the soup. And what I get is 17.7 recurring. So how many full cups of soup can you get from the saucepan? So I can only get 17 full cups. It doesn't quite fill the 18th. Okay, they were good questions. Monday. Okay. Right, so we go back in here, and the last, is this the, yeah, so this is the last bit of the ordinary level book. Although I will say those homework questions were not ordinary level. I mean, they're in the book, but you'd never get them at ordinary level. So anyway, the last thing in the ordinary level book is scaled diagrams, okay? So this is the idea, I don't know, has anyone seen Zoolander now? If you do, you will have seen the scene where he doesn't understand the concept of a scaled diagram or a scaled model. But essentially, if you are renovating your house and the architect draws a plan, he doesn't draw a plan exactly the same size as your house. He scales it down so that it fits reasonably on a piece of paper. When we draw a map of Dublin, a map of Ireland, a map of the world, we don't draw it to scale because that would be ridiculous. We scale it down so that it fits into a map. Okay, I know we don't use maps a whole lot anymore, and I have a feeling Mr. Harrington told me that you don't do it in geography anymore, map reading. But I'm assuming at some point you've all seen a map. There's a map of America in front of you. It is America, isn't it? Yeah. So obviously, that's not the size of America. It's really, really big. But to draw a map, you scale it down. Okay, so that's what this is about. It's about the concept of scaling, all right? Where 1 centimetre on a map might equal 5 kilometres in real life. Okay? So we'll have a look at the question. This is reasonably straightforward, I think, I hope. Okay. So the map shows the distance between 2 cities, Dublin and Cork. On the map, the distance between Dublin and Cork is 5.1 centimetres. In reality, the actual distance between Dublin and Cork is 255 kilometres. On the map, how many kilometres does each centimetre represent? Okay, so we know that 5.1 centimetres is 255 kilometres. Yeah? And they want to know how many kilometres does 1 centimetre represent? Okay? So this is like the stuff we did when we were doing the financial maths. How do you get from 5.1 to 1? You divide by 5.1. And then you just do the exact same thing over here. So 255 divided by 5.1 is, sorry now, let me take the question mark out, is 50. So 1 centimetre represents 50 kilometres. Okay? So then, Donegal, if Donegal is 8 centimetres from Cork on the map, how far is it in real life? Okay, so Donegal is 8 centimetres. And we know that 1 centimetre represents 50 kilometres. So we're going to multiply that by 8. And that gives us 400 kilometres between Cork and Donegal in real life. And that's it. That's scaling. Okay, so obviously they could give you any map and any distance, and whoever drew the map can do it to any scale, but it's the same idea. So it's the same stuff that we were doing when we were doing percentages and VAT and all that. It's just about whatever scaling occurs on the map has to occur in real life. They have to be equivalent. Okay, so when we started over here, whatever change we made over here, we had to make the same change on the far side. Likewise down here, to go from 1 to 8, I don't know why I didn't put that in. To go from 1 to 8, it's multiplied by 8, so we apply the same thing on the far side. Okay, have I got another nice question? Ah yeah, do the house. Okay, so this is a sketch of the floor plan of a house, and it's been scaled 1:50. So give that a go for Wednesday. And then, let me just, oh no, sorry, you're not third years, second years. Area volume. Yeah, so then that's us finished that second chapter. So we'll be moving in then to the higher level chapter after that. And again, same as what always happens with the higher level chapters, a lot of it we've done already. So there'll be a lot of kind of just skipping through and just trying a few questions here and there. The bulk of this chapter, or the most important parts of this chapter, are the 3, where are they? Oh, we have to do presents. The 3 higher level questions. Oh my god, can't find them. Anyway, there's 3 higher level questions at the end. One is about immersing something in a liquid, so they're immersion questions. One is about water flowing through a pipe. And I can't remember what the third one is, but there's 3 kind of, and they're the ones that are always asked on the higher level paper. So yeah, it'll probably take us, I don't know, maybe a week and a half to get through that last one. that higher level chapter, and then we're done with area and volume, which is great. Okay, so homework for Wednesday is the floor plan on the scale diagram. All right, let me know if you run into problems.